All right, so my name is Joe. I'm with Databricks, solutions architect, joined by Barak, one of our really good engineers, and Steven, another solutions architect. Today we're going to be doing a Delta tutorial. So you guys heard in the keynote yesterday a bunch about what Delta does. We have the same slides, but we're not going to talk through them a bunch. We're going to go ahead and get you guys a tutorial to go ahead and actually follow along. So in order to do this tutorial, if everybody could go to community.cloud.databricks.com and create an account. This is the Databricks Community Edition, completely free to use. It's just kind of a nice, easy way to learn Spark. If you don't want to do the tutorial, you just want to follow along and watch us, you don't need to do this. Once you get there, we'll show you how to do this in a second, but you'll import our Delta notebook. And what this will do is just kind of give you a bunch of code that explains what we're doing, why we're doing it, and how it's working. So how we'll do this is we'll spend about 5 minutes just recovering what we talked about on stage in our keynote, and then Barak will come up and actually do the tutorial with you guys. All right. So I'll actually leave it here for 1 second. If you have questions while we're doing this, we purposely picked we'll talk at you for 5 minutes and then do the tutorial after. If you have problems getting to this or you forget the link, just put your hand up and someone will come around to help you out. All right, so on to Databricks Delta. So everyone over the last 5 or 6 years have been collecting tons of data into this thing called the data lake. And they've spent these millions for promises on greater returns via machine learning and artificial intelligence. So they expect to spend, if I put $1 million into my data lake, I'll make $2 million because I'll have a better recommendation engine. And this has kind of been the idea of how large enterprises have gone, or even startups have gone ahead and justified these data lake costs. When they go ahead and they try to actually execute on these projects, they find there's a lot of issues just with the data itself. So the data is really unreliable. Unreliable data is very ineffective data. It's very low quality data. This low quality data creates low quality projects that fail quite often. So, why are these projects struggling with reliability? And these projects start struggling with reliability in a few places. So the first is failed production jobs. So with a lot of the big data technologies, when you're running a production job and it happens to fail, there's no really kind of concept of a transaction. So when you go ahead and you try to roll back, you end up having either a really clever script or you have some unlucky admin that's searching through S3 to go ahead and delete these partially written files. So failing production jobs, you have kind of untrustworthy data. The next part is lack of schema enforcement. So the Hadoop vendors of the last few years have done this really good job of pushing this thing called schema on read. And that's it's a really good concept until you need to use the data. So by being able to put whatever you want into a data lake, well, I guess when you don't have guardrails, people kind of fall off the road, right? So when you don't have any sort of schema enforcement, people start to create things with lots of schema. When you have lots of schemas that are inconsistent, when you try and process inconsistent schema in your data lake, you have your data scientist has a really bad time. And then the last part here is just lack of consistency. So we're building these data lakes. We want to build these recommendation engines. We want to build these streaming applications. We want to do batch analytics. We want to do real-time analytics. When you want to mix reads and writes, batch and streaming, without consistency, you run into a lot of troubles. And that kind of frames up why we built Databricks, or why we built Delta Lake. So Delta is really our response to seeing all of our customers that went ahead and had these problems. When we built it, we had kind of 3 concepts in mind. So the first is we're a true open source company, so we wanted to use an open format, and we chose Parquet. We added transactions, so we wanted to add value to this format. We didn't want to just open source something and expect people to use it for no reason, so we wanted to add value, and that value that you get with this is transactionality and a couple other things. And last but not least, we wanted to make it work with the Spark APIs. So how many people are familiar with like ORC and Parquet? And when you write or read those, what's the difference? The name, right? ORC, or read Parquet. So with Delta, it's the same thing. It's just changing the verb. So we're going to focus kind of on how the Delta Lake makes data ready for analytics from the reliability perspective. So if we look at the 4 kind of callouts that we like to bring to your attention for reliability, is first and foremost ACID transactions. So what that really means is when you do a write to a table, it either entirely completes or it doesn't exist. So we have what's called a transaction log. That transaction log keeps track of how things flow into the table. When you're able to keep track of transactions, you now don't have to worry about things failing and leaving partial results. The next part is schema enforcement. And actually, schema enforcement and having a smart way to basically evolve your schema. So we've added things, basically schema on write. If it doesn't fit a schema, it'll fail your write. The next 2 pieces here, unifying batch and streaming. So with Delta, you have the transaction log. It gives you consistent views of your data. So even as you're streaming data in, the person that's reading that table that's sitting on top of the Delta Lake is going to see a consistent view. And then the last part, which is kind of like an unintentional side effect that's really beneficial, is we can do time travel. So with the transaction log, we can actually say, show me what the data looked like yesterday, show me what it looked like 5 days ago. There's a lot of value in this when you start talking about reproducibility, auditability, explaining how things have changed. So that's kind of the 4 pieces we have. All right, for references, we do have a couple pages. So the home page is delta.io. We do have a really nice docs that go ahead and kind of explain everything that's in the Delta Lake. So with that, let me go back to the slide where we had the import for Community Edition, and I'll pass it over to Brock.
All right, thanks, Joe. So I'm going to switch over to Databricks real quick, and we'll have the link up there as well. So if you manage to sign into Community Edition and you're following this tutorial, this is the homepage that you're going to land into. So the first thing that we're going to do is launch a cluster. So for this cluster, we're going to create a managed environment for you of like only 6 gigabytes. Give your cluster a name, and the only thing that you have to change is use runtime 5.3. And that's it. That's the only configuration change that you should do. You don't need to play with anything else. And then you're going to click Create Cluster. So while that's running and creating your cluster, then you can click on your home to go to your home folder. It'll likely be empty, not unlike mine. And then you can either right-click on an empty space in your home folder, or you can click the triangle up top and select Import. So once you select Import, you can enter the URL to our notebook. So it's going to be Delta.io notebooks and SAIS 19-tutorial.dbc. So once you click Import, that's going to create the notebook for you. And you should be able to see this page. So I've put up the link up here as you import your notebook. And what I would like to talk about is kind of give you a sense of what we're going to do today throughout this tutorial. So, the core abstraction of a Delta Lake is an ACID-compliant Spark table. And as Joe mentioned, the data is stored as Parquet in your blob storage. It could be HDFS, it could be S3, it could be Azure Blob Storage. And what Delta does for you is a layer on top of your remote storage that manages the metadata and the file layout of your data lake. So through this, we can provide you features like snapshot isolation, which means that if you have certain writers writing to your Delta Lake, and you have a query running on your Delta Lake at the exact same time, the query will run on a snapshot of your data that's unaffected by the write that's coming in to your Delta Lake. So if the query fails or it has to restart, it will reuse the same snapshot, and you'll get consistent answers throughout, if you have any faults or distributed failures. In addition, you get ACID transactions, and what that means is if a transaction completes, everything appears atomically. So it's a all or nothing operation. If there is a failure, if the transaction fails, your readers will not see any garbage data. Your readers will not see any side effects from that transaction that failed. So today what we're going to build is, our scenario is pretty much, let's say we have an IoT use case. We're a new company. We have our IoT devices. It's going to send a lot of data, and then we want to do some near real-time analysis of our data. And the goal is to be eventually, build a nice data lake where we can build our reports, where we can actually train machine learning models, and also create dashboards around how our IoT devices are running. But the biggest issues that we see is that we're a fast-moving company. We haven't figured out everything yet. It's so we want flexibility. We're going to need to change our schema over time, multiple times probably, because we're going to make mistakes. And then we're going to add new columns to our schema. So we want to be able to do those kinds of changes. And on top of that, since we want to get near real-time processing, we've heard about this issue of small files in your data lake. If you have a ton of small files in your data lake, you have two issues. One is, first of all, figuring out what those small files are. So if you would just query a regular Parquet table, you would have to list a bunch of directories just to figure out, okay, these are the files that I need to use in my query, which is expensive if you're actually connecting to something like S3 or Azure Blob Storage. On top of that, another issue with small files is that all the HTTP connections that you have to open to these files. In the same time that you open a connection to a file, you could process probably 4 megabytes of data. So you're losing a lot on throughput just because you have a ton of small files instead of just one big chunky file. So we want to be able to solve that problem transactionally and not also cause any of our downstream reports or analyses to fail because of such compaction operations that we're going to run, hopefully pretty frequently. So for this problem, we want to use Delta Lake. And let's start with just looking at how we would build such a thing with just regular Parquet. All right? So I have my cell here in Databricks. I'm going to do some setup of paths here. I'm just creating 3 table paths where I'm going to store my data. In Databricks, you can run your commands by clicking up, the top right. You can click Run Cell, or you can use the shortcut Shift-Enter to actually run the cell and then jump to the next cell. So once you run this first command, let's see how we would build such a thing with Parquet. So we're using some auto-generated data so that you can use this, redo this tutorial once you go back home, or however many times you want. You can copy and paste this code into Spark Shell and do it later if you want. So what we're generating is just 10,000 records. We have 3 columns. One is action. So the action is either an open or a close action of our IoT device. Then we're going to have dates. And by the date, it's we're getting event time updates from our IoT devices. And we're getting dates range from the 1st of April all the way to the 30th of April. Things are, we're getting some late data from 20 days ago. And we can also get some data in the future because bad firmware or bad manual clock settings and whatnot. And then we have our device IDs. from like 0 to 99. It's like we're launching with our first customer. Let's see what happens, all right? So I'm running this command. You can see that we have our action of string type, date of date type, and device of integer. We're going to write this out to Parquet, and then we're going to partition it by date. Partitioning by date is, a good practice because, if we're going to be flexible and then, business logic is going to change over time, we're going to have like nice boundaries of, like, okay, I pushed the new firmware on like the 25th of April, so okay, if I need to do some reprocessing, I can probably do it after like the 25th of April. So I just wrote out my data. Let's see what it looks like. Display is a function in Databricks that allows you to get a nice view of a table instead of just using dataframe.show. All right. So we have our open and close actions, we have our device IDs, and we have our dates. So if we wanted to group by our actions and count how many actions there are, we're expecting like 5,000 opens and 5,000 closes. Let's see how fast this runs. Okay. So we got our 5,000s. Now, okay, I've done my POC. Things seem to look good. So now I'm going to start streaming my data in. So for streaming, I'm going to use structured streaming. And we have this inbuilt source called the rate source. With the rate source, I'm just going to generate 10 rows per second. And I'm going to still have the same schema of actions, dates, and devices, exactly the same way. And let's see, once we start our stream, what happens. So within Databricks, you can check the status of your stream by clicking this button up top. You're going to see that, okay, we're getting some data in. Some batches are being written. Let's see what our counts look like now. So we expect, some open actions being committed to our table. Oh, wait. I now have only opens, and I've pretty much lost my closes. So what happened here? The issue is that you can't combine batch and streaming with the open source file sync implementation in Apache Spark. The reason is with structured streaming and the open source file sync, what happens is we write out a transaction log similar to what Delta Lake has. It was kind of like the dumb version or initial try at building Delta, I would say, at Databricks. And you can see that once you write the stream, that gives you exactly one semantics because we know exactly which files we've written out. But because I wrote the batch data first, there's no way to recover that, oh, this batch data was already there and is actually a part of my table. So you kind of lose that with open source. But let's see what happens when you use a Delta Lake, which is also open source now. So it's the exact same code, and the only change is changing from format Parquet into format Delta. And I'm still partitioning by my date, and I'm writing to my new directory for my Delta Silver path. So if I now group by and count my actions, we should expect to see 5,000 opens and 5,000 closes. Yay. So, EC2 performance is variable, but generally, if you compare the time it took to perform this operation with Parquet versus Delta, 9 times out of 10, Delta should be faster. And the reason is we didn't have to list any files when we were actually making our query to a Delta Lake. We already knew which files were committed to our transaction log, so we already had that information. We just read those files directly to perform our operation. So as this scale grows larger and larger, you're going to see greater and greater speedups there. So if we start writing out our stream data, now we should be able to unify both our stream and batch processing with Delta. So as we get in a couple batches with some data in, we should now be able to see that we still keep the closes, and then our opens are starting to increase. Yep, so we have 130 new records. So as a next step of our pipeline, I mean, like querying this table was a little, even though there's not that much data in it, it was, a little expensive. So what we want to do is we want to add a second refinement layer to our data. So what we're going to do is we're going to stream out of our, silver delta table, which contains our information. I'm going to read like 10 files at a time. And I'm going to materialize a view of, a group by count by actions, dates, and device IDs. So eventually I will be able to query this gold table from my BI tools or whatever. I would be able to expose this information to, business analysts, and they'll be able to get, interactive, business speed experiences through these tables. So again, I'm using structured streaming. My output mode is complete. What this means is that every time I do a batch, I'm going to compute the new counts, and then I'm going to write out the full table every single batch of counts. Excuse me? What are your other options regarding output modes? So for output modes, your other options are update mode or append mode. For append mode, you would need to add watermarks to your data. Because with append mode, what we say is once we output the data result, we don't want to be able to, we can't, retract it. So we need to make sure that the data is not going to change from then on. So if I run this again, now we're going to get the new data, new counts. There we go. So our streams are running fine. So great. But now I have a couple customers. So we need to make a change to our schema. I'm going to add a user ID column to my schema this time. So let's see what happens when you try to write out to Delta the new schema. So it's going to initially fail. It's going to say, oh, a schema mismatch was detected. There's this new column. Do you really want to add this new column to your table? I mean, I've made many examples, mistakes over my data engineering career when I, messed up the schemas of tables far too many times. So this is kind of like a strict mode to make sure that, you are aware of what's going on. But, this doesn't mean that you can't evolve the schema of your table. All you need to do is add this option, merge schema, true, and this should allow you to add new columns to your schema. And regarding schema evolution, the kind of operations that we support right now, it's only the addition of new columns. If you wanted to rename columns, one way to rename columns is, once we add support for SQL, you'll be able to define views over your table. So that would be one way to rename a column. Or later on, I'm going to show another option called overwrite schema, which if you're writing in overwrite mode, you can totally change the schema of your table completely. So let's move on to ACID transactions. I've just made a change to my table. I said merge schema true, so I've changed the schema. Let's see what happened to our streams above. So if you look at the stream, it's going to say, oh, there's a metadata changed exception. Our stream was trying to make a write to our table, but then the table got a commit that changed the whole metadata of the table. So in that case, it's not safe to actually make this stream continue to operate because we don't know what the new state of the table is. So we give you an exception saying, hey, the metadata changed. Are you aware of this? And if you are aware, just like retry, you can retry, and then this will continue to operate. So this is another great way to see that, okay, like we have extra checks and balances to prevent from, that prevents me from actually messing up my table. And as you see here, our downstream stream will also say, okay, the source stream has a new schema right now. Are you aware of this? If not, just restart the stream, and then we'll start adding our new schema downstream to our downstream tables. So what I'm going to do now is, okay, so I've added this user ID column. What I'm going to do is I'm going to do a humongous backfill. I'm going to take all my data before May 1st. And then I'm going to add, if my user ID exists, I'm going to use it. If it doesn't exist, I'm going to just generate a user ID for it. And I'm going to do this operation called replace where. So we're doing a overwrite mode save, which means that normally this would mean that you would overwrite your entire table. But what we're doing here is by using replace where, we're actually overwriting specific partitions directly. And this is kind of like equivalent to Hive-style dynamic partition overwrites. But we didn't want to build dynamic partition overwrites because we think it's kind of bad practice in the sense that you have no idea about what you're writing, and there are easy ways to actually corrupt your data. So we've seen a lot of customers messing up their tables just because they used dynamic partition overwrites, and then they lost a lot of their data. So our alternative is replace where. You make a conscious decision to actually provide a predicate that says, OK, I am updating these partitions specifically. And as you can see, I actually had a typo here. I said that I'll read all the data from before May 1st, but I tried to write it all into date equals May 1st. And what Delta did is that it said, oh, the data that you wrote out just now does not match your replace where predicate. So, go and fix it. Or, just so you know, it's like you're not doing something right with your pipeline, or you're getting something wrong in your pipeline. So, thank God, I can go and just change this to less than equals May 1st. And then I get my right to go through. The schema mismatch exception where? Sorry. Which stream? The first stream or the second stream? The gold stream. This one, yeah. Command 30 or command 28? Yeah. It's command 31. Oh, for this one? Yeah, no, that was the merge schema example. So the first one's going to always fail. We had to provide the merge schema specifically. Oh, command 32, yeah. All right. So now our write went through. Let's start processing our stream again into our gold path. And now what we're doing is we're also grouping by user IDs now. We've changed our checkpoint location because we've changed the logic of our stateful aggregation. And then we're again partitioning by date. And then we said overwrite schema equals true, which said, OK, my Delta table here, it has a completely new schema, just blank overwrite it. And if I start querying my table right now, it should process a lot faster because we tried to write out one file per partition by doing this repartition operation here by date. So yes, we've already processed all the way to May 1st. Here. So let me stop the stream. The next step is time travel. So Delta Lake, the transaction log is stored aside your data path. So if you look into this Delta log directory, you're going to see a whole list of commits that came in here in JSON. So what we're going to check is, so we did like 2 additional commits on top of our table. After our merge schema option, we first did the merge schema equals true. We changed the schema. And then we did this full backfill. So we're going to take a look at the latest version of our table, as well as how it was before our schema change. So let's quickly look at the latest version. You can see it has our user IDs. The count of it is around 12,000. That's great. So if we look at, we can use the option called version as of to actually travel back in time. Here you can provide a version number of your table, which you can figure out by listing this directory. Another way to actually travel back in time is to use timestamp as of. And with timestamp as of, it can give like dates and such. And as you can see here, once we've traveled back in time, we don't have the user ID column anymore. So, and if we look at how many records there were in this table at that time, we're going to see that it's going to be less than 12,690. Small file problem. Hey, yes, we have 11,690 here. So we're going to be open sourcing a lot of commands and APIs for Delta Lake. One of the commands that we have that allows you to actually look at the changes that happen to your table is describe history. And as you can see here, you can see the versions and the timestamps that correspond to the history of the table. And then, within Databricks, we give you information around which user did it, what were the operation parameters, and what kind of operations that you actually did, and from which clusters. So these will be coming in like future Delta Lake releases as we figure out how to plug in all these like SQL commands into open source. But that's all I wanted to show about time travel. And Delta Lakes. So if you have any questions, I'm happy to take them.
If you guys have questions, please raise your hands and wait for us to bring a mic to you so everyone can hear what you're asking.
So you talked about partitioning based on date, right?
Mm-hmm.
So and you talked about adding a new schema evolution.
Mm-hmm.
So can we do add partitioning dynamically? I mean, as part of the schema itself?
I see. If you can change the partitioning, you would have to overwrite the entire table and use overwrite schema to be able to do that. So you won't be able to change partitioning as the over time right now.
Okay. Okay.
Yeah.
One question about the data table schema. Is there like another system where I have my actual schema version so that other systems might be aware of also? I'm thinking in the direction like something like Hive Metastore or something like the Confluent schema registry.
Confluent schema registry. Yeah, that's a great question. So the schema right now is only stored in Delta's transaction log. But since it's now open source, open format, we should be able to build connectors to these systems to be able to share this information. But it's going to be a little tricky because we don't want to have a split brain situation of the Delta's transaction log saying one thing and then some other service saying some other thing. So that's going to be a tricky part there.
So this transaction log is helpful for to go back with the time travel, right? So that so in the time travel we are able to see all the versions. What are the changes we have done?
Could you speak a little louder?
Yeah. So in the time travel we are able to see all the transactions.
Yeah.
In the format of versions, what kind of changes we have done so
Yeah.
far, right? So all this information is coming only from the transaction log.
It all comes from the transaction log.
Right. So is the transaction log is going to be customizable, or how much worth of information it will have? It's like 2 days, 3 days, 5 days?
Great question. So the transaction log by default is 30 days worth of, we keep a retention of 30 days. You can extend it up to, however long you want, or you could even turn off the retention. So, we'll keep everything over time.
So let's say somehow I got messed up some data with the version. The current version is, let's say current version is 30, but I wanted to restore with the current version is the previous version to 25. So in that case, is there any option we can go back and restore the data as of the version 25?
One way to do that will be to, right now, like a hacky way to do that would be to delete all the transactions that came after it. Version 25, just like have that be the last version. But we'll build a little bit more smart solutions, which actually, does the reverse of all the transactions that came after 25. So
with this Delta, are we guys doing any kind of snapshot mechanism here?
Snapshot what?
Snapshot mechanism, like for each and every version change, the data is going to be stored as a snapshot of data?
Yeah. But it's all like incremental snapshots. It's not like we're snapshotting the entire data every single time. So it's like, the state of the table is like increasing over time. So, if commit 5 added like 5 new files, we're not duplicating everything for commit 5. It still has, like commit 1, commit 2, commit 3, and commit 5. So.
All right, guys. In the interest of time, I think we'll have to cut the questions off here, but we'll still be here for the next 10 minutes. So if you didn't get a question answered, please come up to the front, have a chat with us. Otherwise, thank you very much for attending.